This is the University of Hawaii Maui College, the college on Maui.
Aloha and welcome back to General Pharmacology. Let's talk about basic pharmacology math. Got math? You better got math. You're going to need math in this business, and you're going to need to be able to do it very well. There's people out there called your patients who expect you to do your mathematics 100% correctly 100% of the time. Of course, I just call this burger math. There's a reason I call this burger math. I'm sure it has something to do with a physics teacher was doing a proof one day, and we sitting in the class were half asleep, wondering what he was talking about, and when we said, we're not really sure how you got from there to here, he said, well, I can do the same proof using pickles and hamburgers if that would make it any easier for you. And we figured out that that made sense, and so I think that's the first time I ever heard this system of math called burger math, because our physics professor could do this with pickles and hamburgers. I'm sure it has nothing to do with the fact that I've seen every SpongeBob episode that's ever been made, at least more than once. So here in Krabby Patty Land, we have a very simple rule. We put 3 pickles on every hamburger. Can you remember 3 pickles on every hamburger? And so 3 pickles on every hamburger is the theme. To succeed at Burgerland, you must know how to say 3 pickles on every hamburger in every possible way. Well, we can say 3 pickles for every hamburger, or 3 pickles per hamburger, or a hamburger has 3 pickles, or a hamburger per 3 pickles. 3 pickles per hamburger is the same thing as a hamburger per 3 pickles. The reason we go through all this is to understand that there is a million different ways to say 3 pickles on every hamburger. And when people read word problems, they get all confused what those words mean. And what I want you to be able to do is take those words and extract very simple mathematical information. Well, this is from our legal department. This is the most complicated way to say 3 pickles on every hamburger, and I'm not even going to read that. Or we don't have to use the English language to confuse everyone. We can use Greek letters and symbolic reasoning. One of the objectives in this course is to use symbolic reasoning, and we can use symbolic reasoning to confuse everyone. And so here we're using fractions and letters, and we can use Greek letters too. I'm not even sure what those Greek letters mean. 3 PCS, so that's pickled cucumber slices, per ground beef sandwich is equal to 3.3 times 10 to the minus first ground beef sandwich over pickled cucumber slices. And so when you go and read math problems and word problems, you're going to see some very difficult nomenclature. I just want you to be able to take that information and make very simple mathematical formulas from it. So after all that, this is what I want you to take away from 3 pickles on every hamburger. 3 pickles over 1 hamburger is equal to 1 hamburger over 3 pickles. This is the most important part of burger math. That's why this is the unifying theorem of burger math. 3 pickles over 1 hamburger is equal to 1 hamburger over 3 pickles. See, if I take 3 pickles is equal to 1 hamburger, bear with me. I know that's hard for a lot of you who have more than 3 pickles on your hamburgers. But if 3 pickles is equal to 1 hamburger, and we divide both sides of the equation by 1 hamburger, we get 3 pickles over 1 hamburger is equal to 1. If we take 3 pickles over 1 hamburger and divide both sides of the equation by 3 pickles, well, then we have 1 is equal to 1 over 1 hamburger over 3 pickles. So that's the proof for 3 pickles over 1 hamburger is equal to 1 hamburger over 3 pickles. Well, maybe this is easier for you. 2.2 pounds is the same thing as 1 kilogram. 2.2 pounds equals 1 kilogram. And if we divide both sides of the equation by 1 kilogram, then 2.2 pounds over 1 kilogram is equal to 1. If we take 2.2 pounds equals 1 kilogram and divide both sides of the equation by 2.2 pounds, then we get 1 is equal to 1 kilogram over 2.2 pounds. So notice 2.2 pounds over 1 kilogram is equal to 1 kilogram over 2.2 pounds. When we have numbers with units, we can turn those fractions upside down. These little lines, they might seem like division and fractions, but they're also little equal signs when units are involved. And a lot of people are confused by the fact that we can take 2.2 pounds per 1 kilogram and flip that upside down and make that 1 kilogram over 2.2 pounds. Look, 1 is not equal to 2. I know that. And when you learn math with just numbers. But 1 pair does equal 2 things. And so when we add units to our numbers, then we end up with a new set of thinking, a new algebra. That's why sometimes this is called units algebra. Other people will call this dimensional analysis. So keep that in mind. That's why 1 pair over 2 things is equal to 2 things over 1 pair. You guys have seen that proof. So back to Krabby Patty land. 3 pickles over 1 hamburger is equal to 1 hamburger over 3 pickles. You can do this with any formula. So although you can do this with any formula, you must be very careful to use the correct inversion. So when we use our pickle hamburger equation, are we going to use 3 pickles over 1 hamburger or 1 hamburger over 3 pickles? 3 pickles over a hamburger or 1 hamburger over 3 pickles? Same thing when you're converting pounds to kilograms and kilograms to pounds. Is it a kilogram over 2.2 pounds or is it a 2.2 pounds per kilogram? Do we divide by 2.2? Do we multiply by 2.2? And everyone seems to get confused, especially in the middle of the night when whatever you're supposed to be using to do math doesn't work so well. So that's why I like this system. We can put the pieces of the puzzle together in a very simple way, using very simple logic to arrange our units, so we don't ever have to wonder, do we multiply by 2.2 or divide by 2.2? So how many pickles do you need to make 1,000 hamburgers? Well, how many hamburgers can you make from 732 pickles? Can you do this math in your head? Well, you can do that in your head rather easily. If it wasn't 1,000, if it was a different number, you might have difficulty with it. So the question is, how many pickles? Since the question is how many pickles, then the answer is how many pickles. I think our question was how many pickles do we need to make 1,000 hamburgers? That's what we're working on right here. How many pickles do you need to make 1,000 hamburgers? Well, since the question is how many pickles, then the answer is how many pickles. And since the answer is how many pickles, pickles is in the numerator. That's the top part of the fraction. The bottom part of the fraction is called the denominator. So when the answer is just pickles or any unit, that's the same thing as that unit over 1. So since the question is pickles, the answer is pickles. So we picked this pickle formula right here, 3 pickles over a hamburger. That's the pickle formula that I've picked, and I'll show you why in just a little bit. The answer is 3 pickles is in the numerator, just like pickles is in the numerator of our answer. We can multiply what we know. 1,000 hamburgers, we know we need 1,000 hamburgers, and we multiply that by 3 pickles over 1 hamburger. We should come up with the correct answer, 3,000 pickles. Congratulations, that was very difficult. And this is the part where people think I'm completely insane. However, a lot of the math that many of you have a problem with is just this simple right here. And so if you can make the math this simple, then math will be much easier for you in this course. And the reason we put pickles in the numerator of the formula is because pickles was the answer. Because the question is how many pickles, then pickles must be in the numerator when we set this up. Look what happens if we use the wrong inversion of our pickle formula. What if we have 1,000 hamburgers and we multiply that by a hamburger and divide by the 3 pickles? Well, then we end up with 333.3 square hamburgers per pickle. And that wasn't a question. The question wasn't how many square hamburgers per pickle. The only person who's going to want to know that is maybe the architect. If the architect asks us, how many square hamburgers per pickle? Oh, well, then that would be the correct answer right there. But the question wasn't how many square hamburgers per pickle. The question was how many pickles. And so that is how we use this setup right here. And so 1,000 times 3 is 3,000 pickles because the hamburgers cancel out. A hamburger divided by a hamburger is equal to 1. And multiplying 1 times anything is a complete waste of time. That's how these units cancel out. That's the word we use, canceling out the units. Because anything over itself, whether it's a number or a unit, is equal to 1. And so a hamburger divided by a hamburger is equal to 1. That's why we're left with 1,000 times 3 pickles. So how many hamburgers can you make with 732 pickles? Well, we'll use burger math to figure this out. Well, the question is how many hamburgers, and since the question is how many hamburgers, the answer is how many hamburgers, and since the answer is how many hamburgers, hamburgers is in the numerator. Because hamburgers is in the numerator, hamburgers is going to need to be in the numerator when we set this equation up. Because the answer being hamburgers is the same thing as hamburgers over 1. Dividing anything by 1 is still itself a complete waste of time. So, which pickle formula do you think we'll use in this situation? Will we use a hamburger over 3 pickles? Or will we use 3 pickles over a hamburger? Will it be a hamburger over 3 pickles? Or 3 pickles per hamburger? Well, because the answer is hamburgers, then hamburgers is in the numerator. And because hamburgers is in the numerator, then we'll use our pickle hamburger formula that keeps hamburgers in the numerator. And this time we'll be dividing by 3. So we know we have 732 pickles. And if we take those 732 pickles and divide by 3, notice our pickles are going to cancel out. And the only thing left is hamburgers. Because a pickle over a pickle is equal to 1. And 1 times anything is a complete waste of time. And that's where we get 732 divided by 3 equals the 244 hamburgers. Those of you with your calculators can double check and make sure. And so I show you the system because when we start doing this with pharmacology, people start getting real anxious. And so I just wanted you to see the same gymnastics using pickles and hamburgers because everybody's comfortable talking about pickles and hamburgers. And again, look what happens if we use the wrong version of our pickle formula. This time, we took our 732 pickles and made a mistake and multiplied that times 3 pickles over 1 hamburger. Well, what we're left with is 2,196 square pickles per hamburger. Well, nobody's going to ask us that. Maybe the architect is going to ask us that. And if the architect asked us, well, how many square pickles per hamburger? Well, then that'd be the correct answer there. 2,196 square pickles per hamburger, but that's not the question. The question is how many hamburgers. And since the question is how many hamburgers, hamburgers needs to be in the numerator, and these pickles need to cancel out, leaving only the unit hamburger. Well, a jar has 732 pickles, and 1 case of pickles holds 6 jars. And this is going to be the most complicated setup that you see in this pharmacology class right here. Sounds simple when we're talking about boxes of pickles, cases of pickles, and jars of pickles, but people start getting real upset when we talk about milligrams per kilogram and things like that. So how many hamburgers is going to come from this case of pickles? We got 1 case with 6 jars, and each of those jars holds 732 pickles, and we're putting 3 pickles on each hamburger. So what is the question? How many hamburgers? And how many hamburgers can we make from a case of pickles? And so what pickle formula are we going to use? Are we going to use a hamburger per 3 pickles or 3 pickles per hamburger? A hamburger per 3 pickles or 3 pickles per hamburger? Well, what do you think? Hamburgers is in the numerator here, and case is in the denominator. And since hamburger is in the numerator, we'll start out with our pickle hamburger formula with our hamburger in the numerator. Now that hamburger's in the numerator, hamburger's in the numerator of our answer. So this is going to be the correct formula to use. All right, a jar holds 732 pickles. So are we going to use a jar over 732 pickles, or 732 pickles per jar? Is it a jar with 732 pickles or 732 pickles per jar? Well, if we put the pickles on top, notice our pickles cancel out. Because a pickle divided by a pickle is equal to 1, and 1 times anything is a waste of time. Well, if the question asked you, how many hamburgers per jar of pickles, there would be your answer right there, 732 divided by 3. But the question is not how many hamburgers per jar. The question is how many hamburgers per case. So we need to multiply times our 6 jars per case, or a case per 6 jars. 6 jars per case, or a case per 6 jars. Well, we need jars to cancel out, and the way to make jars to cancel out is to put jars on top. And notice that leaves case in the denominator where we want the case to be, on the bottom. So that's how we use 6 jars per case. And now my jars cancel out, and I'm left with 6 times 732 divided by 3 hamburgers per case. This system works for everything from hamburgers and pickles to chemistry and astrophysics. Those of you who have taken some serious physics classes, some serious chemistry classes, you know that this is the best way and the only way to do calculations with units. That's why this is called units algebra. Some people call it dimensional analysis. I call it burger math because that's certainly a less scary word than what other people call this. Believe me, this works for pharmacology as well. Because burger math is easy. I get all sorts of emails telling me, oh, burger math is just so easy. And yet there's all these people out there who are completely afraid of pharmacology math. So let's talk about some things that you'll need to keep in mind as we go through pharmacology math. Well, pharmacology math has several features that are consistent with each other. Drugs are measured in units. And then drugs are sometimes administered in different units. Pills are a solid. Here, let me go back and explain this right here. All right, so pharm math has several features that are consistent. Drugs are going to be measured in some kind of unit. And then one of the problems people have is the drugs are administered in a different unit. So sometimes drugs will come in milligrams, and yet it'll be suspended in a liquid that's measured in milliliters. And to give so many milligrams of a drug that's in a liquid, we have to know how many milliliters to give. That's why it's important to know burger math. Well, pills are easy. Because they're a solid, we can give them in the same units as they are per tablet. And so if we have to give somebody 1 tablet of a 200 milligram drug, there's not too much calculation involved in that. But something to keep in mind when we go through the tablets calculations is that how many milligrams per tablet is the same thing as a tablet per how many milligrams. We can turn those upside down just like we did with pickles and hamburgers. So drug A comes in 12.5 milligram tablets, which is the same thing as 12.5 milligrams per tablet. Well, how many tablets is 37.5 milligrams? So what's the question? How many tablets? All right. And what kind of math do we see? What kind of numeric things do we see on this question? We see 12.5 milligrams per tablet, and we could write that tablet per 12.5 milligrams. By the way, never, ever, ever write your fractions like this with that slash we have on the keyboard. We do that with the keyboard because it's very easy. Write your fractions the way I do with a horizontal line, and do that each and every time. It'll make it easier for you to do your calculations. So how many tablets is 37.5 milligrams? How many tablets is the question, so how many tablets is the answer? Because how many tablets is the answer, what do you think we'll use? Do you think we'll use 12.5 milligrams per tab, or a tab per 12.5 milligrams? Well, since tablets is the question, tablets is the answer. How many tablets is the answer? So we need tablets to be in the numerator. So if we take our 12.5 milligrams per tab and turn it upside down, just like we did with pickles and hamburgers, then we'll end up with a tab over 12.5 milligrams. And we know that we want 37.5 milligrams of drug. And so we put that right there, and notice my milligrams cancel out, and what am I left with? Just tabs. And so 37.5 divided 12.5 is equal to 3 tablets. And so this is how I do these calculations. Sure, other people are going to show you formulas that you can memorize, and then you can forget when things are getting really stressful. But this requires no memorizing any formulas. This requires just taking logical steps to make sure that you position your tablets or you position your units in the correct place, and all of your numbers will end up where they belong. Well, liquid medication starts getting more difficult. Liquid medication is measured in specific drug units over a specific volume. So liquid medication by mouth is easy, and so is IV push. Let's go back and repeat that. Liquid medication is measured in specific drug units, and so those drug units might be micrograms, milligrams, grams. When we measure proteins, they're measured in units, international units. Maybe you'll hear milliequivalents. And then those drug units will be written in a fraction over a specific volume. And you'll see milligrams per milliliter, or maybe you'll see grams per liter, or units per milliliter. That's when this starts getting complicated for people. Well, liquid medication by mouth is very simple, and so is pushing drugs IV. So drug B comes as a liquid as 20 milligrams of drug for every milliliter of solution. That means there's 20 milligrams of drug in 1 milliliter of liquid. So how many milliliters is 40 milligrams of drug? Maybe you need to give 40 milligrams of this drug, and you have to decide how many milliliters to give of this drug. Well, what is the question? The question is how many milliliters. And since the question is how many milliliters, the answer is how many milliliters. Since the answer is how many milliliters, milliliters is in the numerator. So which one of these inversions of this formula do you think we'll use? Do you think we'll use 20 milligrams per mil, like it's written on the bottle? Or do you think we'll use a mil over 20 milligrams? Well, I'm here to tell you we can turn this upside down just like we did with pickles and hamburgers and put milliliters over the 20 milligrams because 20 milligrams per mil is equal to a mil per 20 milligrams. Just because it comes from the pharmacy written as 20 milligrams per mil, that doesn't mean we can't turn it upside down and put milliliters on top, so milliliters is in the numerator where milliliters belongs. So what do we know? We want 40 milligrams of drug, and by putting 40 milligrams in the numerator, notice my milligrams cancel out because a milligram over a milligram is equal to 1, and 1 times anything is a waste of time. And we're left with just the units milliliters, and now we can take our 40 divided by 20, and we know that we need to deliver 2 milliliters of drug. Sure, a lot of you people can do this in your head, but if I made the numbers a little more complicated, you wouldn't. And this is always the best way to set things up to make sure that you're coming to the correct answer. Like Lasix comes as 10 milligrams per milliliter. Lasix is a diuretic, a loop diuretic. We use it in congestive heart failure and to relieve pulmonary edema. So Lasix comes as 10 milligrams per mil. How many milliliters is 80 milligrams? Well, this is how we'd set this up. Since the question is how many milliliters, then the answer is how many milliliters. And since the answer is how many milliliters, milliliters is on the top in the numerator. So even though the bottle will say 10 milligrams per mil, we'll just take that 10 milligrams per mil and turn it upside down just like we did with pickles and hamburgers. And now we have a milliliter over 10 milligrams. Now we have our milliliter in the numerator where it belongs. And we know we want to deliver 80 milligrams, and so we put 80 milligrams in the numerator. A milligram over a milligram is equal to 1, and 1 times anything is a waste of time. And now we're left with 80 divided by 10 milliliters, which is 8 milliliters. Notice everything we've talked about so far is just as easy as the pickle and hamburger formula that we went through originally. When we talk about pickles and hamburgers, everybody's real comfortable and has no problem with it. Once we start talking about drugs and milligrams and milliliters, people start getting very anxious. Well, you're asked to administer 8 units of insulin to a patient. Insulin is a polypeptide hormone, and peptides are measured in units. Proteins are measured in units. Those are units of protein. You can look up any of that on Google and figure out where those numbers come from. Well, the insulin that you've been given comes as 100 units per milliliter. So how many milliliters will you give to deliver 8 units of insulin? Well, since the question is how many milliliters, the answer is how many milliliters. And since the answer is how many milliliters, then milliliters needs to be in the numerator of our setup. We can take our 100 units over a milliliter and turn it upside down just like we did with pickles and hamburgers. So we end up with a milliliter over 100 units. And we multiply that times the 8 units because we know we want to deliver 8 units. And we get 8 divided by 100 equals to 0.08 milliliters. Well, you're asked to deliver 20 milliequivalents of potassium chloride to a person. And the potassium chloride comes as 40 milliequivalents per 15 milliliters of solution. How many milliliters will you give? Well, the question is how many milliliters, and the answer is how many milliliters. And since the answer is how many milliliters, when we plug in our formulas, we're going to want to make sure that the milliliter unit ends up on top in the numerator. So even though the bottle says 40 milliequivalents per 15 mils, we can turn that upside down just like we did with pickles and hamburgers, put the 15 milliliters on top. So now our is in the numerator. We know we want to deliver 20 milliequivalents. So by putting the 20 milliequivalents in the numerator, we can cancel out our milliequivalents because a milliequivalent over a milliequivalent is equal to 1. And 1 times anything is a waste of time. That's how these units cancel out. And we end up with 20 divided by 40, which is 1/2 of 15 mils, which is 7.5 mils. And I know that math went through your head automatically. And the reason that your brain is able to do that is your brain does these little logical calculations without you even knowing about it. And that's when you're awake, alert, and very intellectually charged. Sometimes you just have a bad day and you can't remember anything. And that's why it's very important to understand this system. Sure, people are going to give you all sorts of formulas to memorize so that you can forget in a very important life and death situation. Sure, a lot of you are going to work for a place where the pharmacist or the computer system does the calculations, and many times those systems can not work or be broken down. Sometimes they can be inaccurate. You, by knowing this, are going to be part of quality assurance, making sure that the right dose of drug ends up in the right person. That's why it's essential for you to understand this system. So when we give liquid medication by mouth, it's pretty simple. We give a single IV push, like we've been talking about. That's all easy. It's when we start talking about IV medication by continuous infusion that's delivered at a rate, then we start having a problem. And we start getting more confused. Something you should know about a rate, it's just like physics. Anything that's a rate is something over time. Like miles per hour is a rate. A velocity is a rate, that's distance over time. In medicine, when we give an IV rate, that's going to be a volume over time. So an IV rate is always going to be a volume over time. So you're asked to administer 1 liter of saline to a person over 4 hours. How many milliliters per hour will you deliver the IV? Well, since the question is how many milliliters per hour, then the answer is how many milliliters per hour. And since the answer is how many milliliters per hour, then milliliters needs to be in the numerator and hours needs to be in the denominator. And so what formula do you think we'll use? Do you think we'll put the volume on top and the time on the bottom, or do you think we should put time on top and the volume on the bottom? Well, a rate is always volume over time, and a liter is the same thing as 1,000 milliliters. And notice we want our hours on the bottom. So putting 1 liter over 4 hours is the correct answer. So now we have liters, which is 1,000 milliliters on top, and we have hours on the bottom. And so this lines up with the way our units line up in our answer. There are 1,000 milliliters per 1 milliliter. You need to know this if you do not understand the metric system. There is a metric system on the YouTube channel, and you can look in your syllabus to figure out where that is. You can just go to youtube.com and go to channel Pharm 203, PHRM 203, and find the metric lecture. You will need to understand the metric lecture if you're going to be in the professional healthcare business, I assure you. Well, 1,000 milliliters is equal to 1 liter, and so 1,000 milliliters over 1 liter is the same thing as 1 liter over 1,000 milliliters. And we put the 1,000 milliliters on top and the liter on the bottom. Notice my liters cancel out because a liter divided by a liter is equal to 1. And 1 times anything is a complete waste of time. And now we're left with milliliters per hour. And it doesn't matter if the 1 liter over 4 hours is in this position and the 1,000 milliliters is over here. A times B is equal to B times A. 3 times 2 is equal to 2 times 3. So these don't have to be in any specific order. I lay them out in this order because this makes sense to me, and then they're laid out in the order that most other people tell you to go. And so now we have 1,000 milliliters over 4 hours, which is the same thing as 250 milliliters per hour, because 1,000 divided by 4 is 250. Well, this gets real complicated for people. 220-pound person is supposed to get 0.5 milligrams per kilogram of drug. How many milligrams is that? And so when we start talking about dosages of a drug based on weight, a lot of people are afraid of this and get confused. But notice this is going to be just as simple as anything we did with pickles and hamburgers. So notice our question is how many milligrams. Because our question is how many milligrams, our answer is how many milligrams. And because our answer is how many milligrams, then milligrams needs to be in the numerator of our setup when we do this equation. And so 0.5 milligrams per kilogram was the dose, and we can just line it up the way it was given, putting milligrams on top, and we end up with kilograms on bottom. Well, notice we weren't given the kilograms of the patient first. Now, some people will say, oh, well, the first thing you do is convert the pounds of the patient into kilograms. Well, that's what we've done right here. We've taken 220 pounds and divided by the 2.2 pounds. And so by putting the kilogram on top and the 2.2 pounds on the bottom right there, look what we've done. We've canceled kilograms and we've canceled pounds. And so 220 divided by 2.2 is the same thing as 100 kilograms, and 100 kilograms times 0.5 is 50 milligrams. And so you want to be able to do these setups. You must know this. QD is each day, which means once a day. And notice that's a little q and a little d. A BID is twice a day. Big B, big I, big D. Capital BID is twice a day. Capital TID is 3 times a day, and capital QID is 4 times a day. Please do not capitalize your QDs, and please do not write these in lower caps because that's considered wrong. Now, I get emails all the time from students telling me, well, my instructor says we're not supposed to use this anymore. Oh, well, that's fine. Don't use this system, but it's very important that you understand this system because we're going to see this nomenclature for a very long time from a lot of people who've been using this nomenclature for about 100 years. And so this isn't going to go away anytime soon. That's why we spend time talking about things that other people will tell you, well, you're not going to use that. Anytime you get a list of abbreviations or Latin terminology that people tell you that you shouldn't use, I can assure you that you need to memorize those and not use them, but at least understand them when you see them, because people are going to write like this for a long time, whether they're supposed to or not. Well, BID is the same thing as 2 doses per day. And that's the same thing as a day over 2 doses. Or you could say, if it's tablets, BID you could say is 2 tablets per day, which is the same thing as a day per 2 tablets. TID is 3 a day, 3 doses per day. And remember, that's going to be the same thing as a day over 3 doses. Or you could say 3 tablets today is what TID is, which is the same thing as a day over 3 tablets. QID is 4 doses a day, and don't forget that's the same thing as a day over 4 doses. Or it could be tablets, it could be anything. It's 4 of those anythings per day is the same thing as a day over those 4 tablets or those 4 anything. And so a lot of people tell me that once TID and QID is involved, that we cannot use burger math or units math or dimensional analysis. And we can, and I think we will eventually show you that. Well, this is important, and I want you guys to be very aware of the concept of something called a leading zero. A child had a severe salt-wasting nephropathy, nephro-kidneys, pathology problem, disease. They had a kidney disease that caused them to lose sodium chloride. So they are ordered to have a 3% sodium chloride solution. 3% sodium chloride is very concentrated. That's not normal for someone to get 3% sodium chloride situated. It's not normal for someone to get a 3% sodium chloride solution. So it'll be very rare. You might see it occasionally. It's very rare for somebody to get 3% sodium chloride unless they have a severe salt-wasting nephropathy. Well, later, this child did great, and they wanted to switch to 0.9% sodium chloride, which is normal saline. And I'm here to tell you the best way to write normal saline is just write normal saline. Don't write 0.9% sodium chloride. Write normal saline, because everyone knows what that is. Well, the order was not written for 0.9% sodium chloride, which is normal saline. It was written for 0.9 sodium chloride, 0.9% sodium chloride. And that decimal point was not seen on whatever was sent to the pharmacist. So the pharmacist prepared a 9% sodium chloride solution, 10 times the amount of salt in this solution. And you'll never see anybody in a 9% sodium chloride solution. And so this turned out to be a fatal error, all because of a missing 0 in front of a decimal point. So in your math class, 0.9 and 0.9 might be the same thing to them, and it is the same thing in mathematical terms. I won't argue that. But in a clinical setting, the difference between 0.9 and 0.9 can be the difference between life and death. And so it's very important that your decimal points have leading zeros. So don't let this happen to you or anyone else. I'm sure you'll have a very, very bad day if you write your digit in such a way that people mistake that for no. If you write your decimal point in such a way that people mistake that for no decimal point. So always use a digit in front of your decimal points. And that's why we're doing this now for fun. This class is supposed to be fun. You're supposed to make your mistakes in this class, so when you get out in the real world, you will have no problems.
This is the University of Hawaii Maui College, the college on Maui.